Welcome back everyone to another episode of the Doom series, and in this video we are going to finally get into the rendering of sector floors and ceilings. Now to start, we are going to open up our engine.c file. Going down into the engine initialize function, we are going to create the floor and ceiling ones as well, and we'll create them in a separate list which we'll call flat node. The reason we need a separate list is because we'll need a separate mesh per flat. So flat will represent both floors and ceilings, and we'll need to have a separate mesh for them. So these cannot be just use the quad mesh, so we're going to change the representation to be a different struct. And in here we're going to just initialize our flat node pointer, and then we are going to set it to our flat list. Then we are going to run a for loop, and we are going to generate a node for each of the subsector in the map. So we're going to go for map, actually not map, the GL maps number of subsectors. And for each of those we are going to go ahead and let's just go here, and the first thing we'll need to do is that we'll need to allocate the memory for a new node. So we'll just copy and paste this here. So we'll allocate the memory for a new node. Then we'll also set the node sector to null by default, and then we'll go down and copy this part where we set the pointers correctly, and we'll change this to set the flat node pointers instead of the wall node pointers. So we are also going to change this to be flat node, and yeah, that's pretty much it. And here we'll need to change the struct wall node to flat node instead, because well, that's the one that's supposed to be in the next one, since this is flat node. And after that we can go here, and we can start to actually get the vertices and everything. So we are going to first of all get the number of vertices, and the number of vertices is going to be equal to the number of segments in this sector. So for that we are going to get the subsector, yeah, the GL subsector. We're going to create a pointer to that and set it to our current subsector that we are looping over. And with that we are going to set the number of vertices to the number of segments in that subsectors, because we'll get the start vertex of each segment. And then we'll create an array of vertices which we'll just allocate using our size of a vector, and multiply that by the number of vertices that we've got, and we'll change this to vec3. And multiplying this by the number of vertices, we are going to well, that should allocate the array for our vertices correctly. And we are going to now populate this array by going over each of the segments inside of the subsector. And we are going to change this to j so that we don't confuse it with the outer one. And we are going to get the segment by using just getting the pointer to the current GL segment, and we are going to add the first segment to this, because this num segment is the number of segments, not the last segment. So we need to get the add the first seg to the j value, and that will give us the correct segment, and we'll get the start vertex of the segment. But before we do any of that, we are going to change this to actually use vertex t, not vector3. That was a mistake. And now let's open up glmap.h, and inside of this we are going to define a macro called vertex is gl. And if the 15th bit of any index is set, that means that this vertex is from the gl maps vertices, else it means that it's from the other vertices. So we're going to check if that is the case, and then if that's the case, then we're going to set our vertex to be from the GL vertices, and we're going to mask the value of 7FFF with this, so that we get the correct value. And if that's not the case, then we are going to just use it directly, and we're going to use our maps vertices, not GL map. Then for the vertex, we are going to just set the vertex position to be our value, and we're going to divide it by 100, since we are going to scale it that way, so that it works with our coordinate system. And yeah, that should get the vertex data here correctly. And after that we can get started with setting the index data, because that's the second thing we need for the mesh. So we are going to go ahead and create the number of indices here. So we are going to say size t num indices, and this number of indices is going to be 3 multiply the number of vertices minus 2. Why is that? Well, because we'll triangulate our sectors, which will form n minus 2 triangles, and we'll need 3 vertices per triangle, so we'll need 3 multiplied by n minus 3 indices. So that's the basic explanation. And now let's go ahead and allocate the memory for the indices. So each index is going to be a UN32, so we're going to just allocate the correct memory for that. And after we have done that, we can just go ahead and use this. So we are going to go over each of our index, and we are going to use two variables here. One is going to be j and the other is going to be k. And for j we'll increment it by 3, while k will just increment it by 1. And we'll use j as actual index of the indices that we are setting, while k will be the value that we'll set. And the first one is always going to be 0, the first index, while the other ones are going to be k and k plus 1. And this will perform a simple fan triangulation. Then we'll call mesh create on our nodes mesh, and we'll pass it the number of vertices, the vertices array, the number of indices, and the indices array here. And going up here, we're going to change this to actually have, instead of having a model matrix, we are going to have a actual mesh in here. Alright, so here now we are going to go ahead and set the sector for each of those things that we have created correctly. So for that we are going to go ahead and first of all let's just check if our node sector is null, which means we actually need to set it correctly, and we're going to check that. And not every segment will specify a sector, so we are first of all going to get the line depth of the segment, but you might remember that not every segment lies along the line depth. So we'll get this line depth here from the maps line depth indices array, but we'll need to make sure that we first of all make sure that the line depth is not equal to the special value of like hex FFFF, which means that it's an invalid line depth. And after getting our line depth, we're going to check if it's flagged tell that it's a two-sided line depth. If that's the case, then we are going to do different things depending on the segment side. So if it's 0, which means that it's a front-facing segment, we are going to first of all go up here and set an in sector, which is going to be our sector index, set it to -1, and here we are going to get our line depth front side depth if the side is 0. If the side is 1, we are going to get the back side depth, and if it is one-sided, then the back side depth doesn't even exist. So first, but by the way, we'll need to actually go ahead and get the sector index like that instead of just setting it to side depth directly. Anyways, if that's not two-sided, which means it's one-sided, we are going to just go ahead and get our front side depth like that. So we are going to go map.side depth, line depth, front side depth, and we're going to get its sector index. So after that, we are going to make sure our sector is greater than or equal to 0, which means the index is valid. If that's the case, we're going to set the sector to this sector, else we'll just let it be null. So now for rendering of this, we are going to go down to where we are actually rendering this, and it's giving an error because it included the C++ version of the header, and don't know why it does that. But anyways, let's go there and run make, and you can see that it gives no errors, which means that well, it is kind of working right now. One thing you need to make sure is that the render.c uses vector 3, so I kind of didn't show that in the previous videos, but you need to make sure you actually do that. And now in the engine render function, we are going to just go ahead and go over each flat node as well instead of the wall nodes. So we'll go over wall nodes, after that we'll go over the flat nodes. For the matrix, we are going to just pass the identity matrix, and for the mesh, we are going to use the nodes mesh instead of the quad mesh. Running make right now reveals that we do get some kind of flats here. Of course, these are not at the correct height or anything of that sort correctly, but well, it is working. So now for the correct height, we are going to use mat for translate. On x, we are going to say 0. On y, we are going to get the sector's floor, divide that by the scale that we have got, and we are going to say 0 for the z. And of course, this needs to be an actual vector 3, not just separate arguments. In the end, we are going to well, let's go ahead and also multiply the light level by 0.9, actually 0.8, to kind of make the floors a bit darker. And now you can see that we do get our floors rendered correctly, and they are rendered at the correct height with everything, and yeah, it seems to be working quite well. So that means that our floor rendering is working perfectly. So the next thing we'll need to do is we'll need to go here and change this to ceiling and draw it again, which means that now our floors and our ceilings will be drawn correctly. So yeah, that's pretty cool, which means that we have got our basic map renderer finalized. Anyways guys, this is pretty much it for this video, and I'll see you in the next one, in which we are gonna kind of fix a couple of problems with our code currently, and after that we can get onto the texture loading so that we can display textured walls and texture floor and ceilings and everything. So stay tuned for that. Make sure to like and subscribe so you don't miss that, and share this video with other people as well, and bye.